Hello and welcome to this online video lecture about titration and titration calculations. By the end of this video, you should be able to perform a calculation to determine the concentration of an unknown acid or base, or use the concentration to go on and calculate the pH of an unknown acid or base. Titration is a very common kind of lab experiment that you encounter in freshman level chemistry courses in universities everywhere, and even in some high schools. So it's not a bad thing to familiarize yourself with, especially if you're going on to study science in college somewhere. So let's get down to it. A titration is basically an experiment where you carefully measure out the volumes of acids and bases while you perform a neutralization of the two. You then use the volume measurements that you make to perform calculations to figure out the concentration and then the pH. So this whole thing is basically set up so that you're dispensing. You've got like we use glassware called burettes, and they're basically like really long graduated cylinders with a valve that you can turn to dispense liquid out very carefully. The valve is actually called a stopcock. That's the name of it. So, but you'll take the burette, and in one of them you'll have the acid, which I'll use red for, even though it's clear. And then in the other one you'll have the base, and I'll use blue for that. And usually what will happen is you dispense into a beaker, you dispense a carefully measured volume of one of the two. Let's just say it's acid. And then you'll add some kind of an indicator, and depending on the indicator it will change color or not because it's going into an acid. And then you move the acid or the base, whatever, with the indicator in it under the opposite. So I'm moving from the acid to the base. And you'll slowly dispense the base into it until the indicator that you've added shows you that the acid has become neutralized. And then you can measure the volume of the base that you added. And so what you end up with when you do a titration is you end up with the volume of the acid that you added, and you end up with the volume of the base that you added. So those are the two measurements that you get directly from the titration, and the volume of the acid and the volume of the base where the neutralization happened. And when neutralization happens, that means you have the same number of moles of acid as the number of moles of base. That's basically what a neutralization does. So we have volumes where the number of moles of the acid and the base are equal, and that's the situation that all of these calculations are based off from. So because of these relationships, the fact that the number of moles of the acid and base are equal, and we've measured the volume, we can set up an equivalency. So let's think about concentration for just a second. If you're thinking about concentration like molarity, it equals the number of moles divided by the volume of solution. So we can resolve this for number of moles, and that's going to basically be equal to the concentration in molarity times the volume, and that equals the number of moles. So if we think about this for a second, you can solve this for the acid because we've measured the volume, and hopefully you know the concentration of the acid, right? So then you get the number of moles of acid. And then you can do the exact same thing for the base. Set up the same equality for the base, number of moles of base. And because we've done this to neutralization, remember up here we said that at the neutralization point, when you hit the neutralization, the number of moles of acid and base are equal, which means that these two expressions basically become equal to each other because these two things are equal to each other. So then you can rewrite those two and set them equal to each other. You can set the concentration of the acid times the concentration, or the volume of the acid, is equal to the concentration of the base times the volume of the base. Now, I'm using a capital M here because we usually measure concentration in molarity. You can use a C there if it's easier for you to remember. If you want to put concentration of acid times volume of acid is equal to concentration of base times the volume of the base. So this, now we've come to the basic default equation that we're going to use for all these titration calculations. You're probably pretty much always going to be referring back to this equation and kind of resolving it with algebra to try to get what you want. I think when I was explaining this fictional setup up here, I think I said that we knew the concentration of the acid. So let's just go up here for a second and we'll throw some fake numbers in. So let's say that the volume of the acid when we hit the neutralization point, let's put this in here. Let's just say, I don't know, let's say it was 35 milliliters. And let's say that we know that the concentration of the acid is, let's just say that it's 2 molar. So 2.0 molar. So it's the base we don't know the concentration of, but when neutralization happened, let's say it was, I don't know, let's say it was 53 milliliters. Well, if neutralization happened and the base you had dispensed 53 milliliters, that's the volume of the base at neutralization. And what we don't know in this scenario is the concentration of that base. We only know that it neutralized 35 milliliters of 0.2 molar acid with 53 milliliters. But that's where this equation comes in. This equation right here is your default equation for figuring all this stuff out. So basically, we know the volume of the acid, the concentration of the acid, the volume of the base that neutralized. What we don't know is the concentration of the base. So we're going to resolve this equation from a concentration of the base. Concentration of the base is equal to the concentration of the acid times the volume of the acid divided by the volume of the base that you put in there. And so for this made-up scenario, you know, this fictitious titration that I did, that I got data from, this would be like the data that you'd get, these volumes and the concentration. So let's see, the concentration of the acid was 2.0 moles per liter. And then we have the volume is 35. And then up here we've got the volume of the base was 53, so that goes in the bottom. And so we would basically pull up our handy dandy calculator. Hold on, let me grab that real fast. Okay, here it is. So we've got basically 2.0, so just 2 times 35 divided by 53. I just realized that those were, didn't do that on purpose, but okay. And so when you divide that out, you get 1.32. So that means that the concentration of the base is 1.32 molar. 1.32 moles per liter of solution. And then you can go on and use that concentration to try to calculate pH or anything else like that that you might need. But that's basically what it boils down to when you're trying to do a titration calculation. You're going to use this formula right here in the box. You're going to resolve it for what you're trying to find, and it's almost always usually either the concentration of the acid or the concentration of the base. Those are the two things that usually you're trying to find because you're going to directly measure the volumes. So you're going to either resolve this for the concentration of the acid or the concentration of the base, as I showed you down here, and then you're just going to plug your numbers in that you got from the experiment, and bang, out comes the concentration that you're looking for. So that is how you do a titration calculation. It's not that bad, especially once you've tried it a couple times, and if you've actually done a titration, it kind of makes a little bit more sense after that. But that's basically it in a nutshell. Thank you for watching, and as always, if you have any questions, please feel free to ask in class.